Hello and welcome back. Now that we have some Pygame knowledge, as well as fixed length header knowledge under our belts, let's combine Pygame with sockets, threading, and JSON to create our own online multiplayer game. By the end here, we'll actually be able to call up our friends and send them over a script and challenge them to a game where we all play from the comfort of our own home. That's just pretty cool. So let's start by opening two new files here. So I'm going to go File, New File. And I'll save this first one as in my dedicated directory, so on my desktop, Python examples, and we'll put this in the multiplayer game. We'll call it client.py, and I'll just put a little comment here. I'll say online multiplayer game client, and I will just save for right now. And then let's open up a second file. So File, New File, make it a text file, Control S to save. We're in that same directory, and we'll call it server.py. And we'll just put a comment here. We'll say online multiplayer game server. And I'll save for right now. Perfect. So let's start by setting the server up here. We'll just kind of like blueprint our server. So the server here is simply just going to run in the background. It will not serve as a player in the game. So we do not need a GUI interface, meaning we don't have to import Pygame over here on the server side. So this is going to be different than what we did in our advanced chat application, where the server also had its own GUI and was someone that could, interact in the chat. However, we won't need Pygame, but we are going to need to import quite a few modules. So let's do those right at the beginning. So we'll say import, and then we will need to import socket. So import socket. We'll need threading. We'll need JSON, and that's going to help us with all of our networking needs. And then we're also going to import a new module here. We're going to import the time module. And we are not going to use Pygame to run our countdown timers on the client side, because the timer may run at different speeds on different machines, and that would be really bad if everybody was playing a game and the timer was moving at different speeds, so one person's game ended while the other person's game was still going on. What we'll do, the time module here will allow us to keep track of time on the server without using Pygame, and then we'll push that time out to all connected clients, so everybody's game will be in sync. All right, perfect. So now let's define some socket constants that will be used and altered as needed for our connection. So I'm just going to put some little lines here to visually show that, hey, these are the things we're going to alter. So we'll say, here we'll say define socket constants to be used and altered. So first we'll get a host IP, so host IP, and we're just going to run our server on our local machine here, so it'll just be whatever the local machine's IP is. So socket.getHostByName, and inside of here we'll do socket.getHostName. So nothing new there. And then let's set our port, so we'll do host port is equal to, we'll use our magical port 12345. All right, wonderful. Now let's define some Pygame constants that can be used and altered as needed for gameplay. So we're going to define some Pygame constants here on the server, even though we're not running Pygame. What we'll do is when our clients connect to the server, we will push these constants out to each and every connected client, and then they'll use these constants to set up Pygame on their end. So essentially, our server will have the ability to sort of tweak some of the gameplay. So let's see. We'll just put here define Pygame constants to be used and altered. So we want to be able to change these things right up at the top. So the first thing that we'll do is we'll set a room size. So room size, and I don't know, I'll just pick a value right now. We'll probably change it. I'll do 400. We'll set a player size, and we'll just pick random numbers for right now. We'll set a round time. We'll do 45 seconds. I'll set an FPS so I can control the maximum frames per second, and then we'll set a total number of players that are in the game, and we'll cap that at 4. So now, one important thing here, for the purpose of our gameplay, the room size must be an integer multiple of the player size. And that's just going to be because the way we're going to define our movement, the player is going to move in increments of its own player size. So if they're not integer multiples, what will happen is the player, or a portion of the player, will move off of the screen. And we don't want that to happen. So I'm just going to put a little check in here. We'll say room must be divisible by player size for correct gameplay, and we'll say adjust as needed. Okay, so how are we going to do this? Well, we'll use a while loop. So we'll say while room size modulo player size is not equal to 0. Because if they are integer multiples of one another, when we do this division, the remainder should be 0. So if it's not equal to 0, then they're not integer multiples. And so what we'll do is we'll just simply take our player size variable, and we'll increment it by 1. So I mean, we could decrement it by 1, your choice. But if the player size is not quite right, I'm going to choose to bump it up to the next biggest correct size. All right, perfect. So now let's outline some of the classes that we'll need on our server end. So I'm going to just put another little line here to indicate that this region of space is the only space we should be altering. Perfect. You know what? Maybe we'll put a check for max players, and I'll just say maximum number of players allowed is 4. So we'll just say if total players is greater than 4, let's just set total players equal to 4. That way, I don't know, if anybody makes a mistake here and they make it like 10, it'll cap us at 4 people. So that's the most that we can have in our game. All right, so now we'll go and define some classes. So we'll say, right down here, we'll say define classes. We're going to blueprint them, and then we'll work throughout the whole scope of these videos, kind of filling these in and writing a functionality. So we are going to need a connection class, essentially to hold our socket connection, just like we've done before. So we'll say def connection. All right, so we have a connection object, and we'll put here a socket connection class to be used as a server. So this is going to hold our connection object, and we'll pass it into all of our other objects and methods. So we'll need an initialization, so def underscore underscore init underscore underscore, and we'll pass in the required self parameter. And I'll just say initialization of the connection class. If I don't say it like that, initialization, I tend to not spell it even remotely correct. All right, next, our connection class is going to allow our clients to connect to the server. Every time a client connects, our server should create a new player and then send it back to the client to use. So we're going to need a player class here. So we'll say class player. All right, and we'll say a class to store a connected client's player information. All right, and so let's think about the methods that we will need here. So we'll have to initialize it, and so we'll say def underscore underscore init underscore underscore. We'll take the required self parameter, but we're also going to take in a number, because if you recall, on our server end, we have a number of players that are going to be playing, total players. We could adjust this to be 1, 2, 3, or 4 at most. So we want to keep track of the player number, and so we'll have to put that in here. And so we'll just say initialization of the player class, and we'll pass for right now. What else do we need to do with our player on the server end? Well, we probably should have a way to set some of the player's information. So if you think about it, the player, there's going to be a player on the client side that the client can control. They're going to change some of the attributes of the player, and they're going to send that information over to the server, and we're going to want to set that information to our representation of the player. So we'll do def set player info, and this will take in the self parameter, and then it should take in some player information. So we'll say player info, and that will essentially be a dictionary that we'll use to update our player. So set the player info to the given info from the client. And so what we're really talking about are coordinates and status flags. And we'll talk more about coordinates and status flags and their importance as we move through these videos. But for right now, we will just pass. And I think lastly here on the server end, we're going to want to reset some of the player's statistics on our end. So we'll do a def reset player, and we'll pass in the required self parameter, and we'll just say reset player values for a new round on the server side. And we will pass. All right, I actually think that's it for our player class. So now we're going to need another class, a game class, to handle all of our gameplay. And this is going to be a huge class for us over here on the server side. So we'll say class game, and we'll put a little docstring here, a class to handle all operations of gameplay. All right, so let's think about what this game class is going to have to do. Well, first we're going to have to initialize it. So we'll say def underscore underscore init underscore underscore. We'll pass in the required self parameter, but I'm also going to pass in a connection object. And we're going to need it because the game is going to have to be able to connect to all of the clients that are trying to play the game. So we'll add that in there. And we'll just say, okay, initialization of the game class, and we'll pass for right now. Next, we're going to need to be able to actually connect our players, right? So we got our connection object now. We should be connecting players to the game. So we'll say def connect players, and we'll pass the required self parameter. That's all we need here. And we'll say connect any incoming player to the game. So, right, this is going to be something that's just constantly listening for people that want to join and will join into the game. Now, as players join, we get multiple players, we might need to want to broadcast something to all players. So we'll say def broadcast, and we'll take in the required self parameter. So far, not too bad. We'll say broadcast information to all players. We're going to want to have a method that is going to help us ready the game, meaning get the game set up for start on an individual client. So what do I mean by this? Well, for example, our game, when you join the game, initially, the game will not be playing. Our game will ask each and every player to hit some button to confirm that they are ready. And once and only once every single player has hit the button, the game will begin. So this function is going to sort of help us monitor whether or not a specific player has hit that button. And so what we'll need to do, we'll say def ready game, is we'll pass in the self parameter. We need a specific player because we're trying to monitor whether or not this player has hit that ready button, and we need that specific player's player socket so we can communicate with them. And here we'll just say ready the game to be played, and we'll pass this. And so this, it will most likely be running in a thread for each and every connected client. So, every client will have a thread running where we're watching to see if this player is ready to play the game. Awesome. Next, we're going to need to have a way to reset the game on the server side and wipe any information for a specific given player. So we'll say def reset game, and we'll pass in the self parameter, and we'll pass in a specific player. And so we'll say restart the game and wipe information for a specific player. All right, so we'll pass that. Maybe I'm just going to say here in my doc string here, ready the game to be played, I'll say for a specific player, just to indicate that we're working with specific players now rather than all of the players that we were looking up here. After we reset the game, what are some other things we're going to need? Well, we're going to need to send a client their player information during the game, such as like updated player scores, times, etc. So we'll need a def send player info method, and here we'll take in the required self parameter, and we're targeting a specific player here with this method. So we'll take in a player, and we'll take in its player socket so we can communicate with it. And here we'll say send specific information about this player to the given client. And This is another thing that will most likely be running in a thread. So you can kind of imagine a lot of these that are targeting individual players. They will run in individual threads for those players. So we have the ability to send player information over to the client. We need the ability to also receive player information from our specific client. But here, what we're going to do is we're actually going to break this up into two separate methods. We're going to have a method that will receive information before the game starts, maybe such as like the button press to ready the game, and then we'll have a different method to receive information while the game is being played, because essentially we'll be passing different information during those times. So we'll say def receive pre-game player info. That will be our before game, and we'll need our self parameter. We want to get it from a specific player, and we need their player socket for communication. And we'll just say receive specific info about this player pre-game. All right, and we'll type pass. We're going to want our def receive game player info. So this is going to be receiving the information from the player during the game. And again, we'll need self, player, and player socket. All right, and here we'll just say receive specific info about this player during the game. All right, and we'll pass. We're doing a lot of good things here. I think the last couple of things that we're going to need is, our game is going to receive a bunch of player info from each and every connected client. Right here. So what we're going to have to do on our end, on the server end, is we're going to have to take all of that information from each individual client, and we're going to have to process it and bundle it together to create what we'll call the game state. And once we have the current game state, we'll send that game state, which holds information about every single player, back to the individual clients so that they can update the game on their end. So we'll need a couple of functions that are going to help us do this. So our first function or method, we'll say def process game state, and this will take in our self parameter, a player, and a player socket. We're going to just say process the given player info and update the game's state. All right, and we'll pass for right now. And then lastly, once that game state has been updated, let's send the game state out. So we'll say def send game state, and we'll say self. And in here, I don't need the player because I'm just trying to send it. All I want to do is send the updated game state. So we'll just grab the player socket that has been running in this given chain for a thread. All right. So def player socket here, and we'll just say send the current game state of all players to this given player. All right, and we will say pass. All right, now before we just kind of end here, we'll just say that essentially when we start the game, these functions will be running, and then once people connect and we have them connected and we're trying to play the game, we'll start a thread for each player where these functions sort of get called one after the other inside of an individual thread for a specific player. And hopefully that'll make more sense as we kind of go out and build this project a little bit more. All right, so now that we have our classes and methods outlined, let's actually start the server. So what do we need to do to start the server? So we'll come down here and we'll say start the server, and we'll first create a connection object. So we'll call it my connection is equal to our connection class, and then we'll create a game object. So we'll say my game is equal to game, and if you recall, if we just scroll up a little bit to our game class, upon initialization, the game needs that connection object. So we'll pass it in right here. So we'll pass in my connection. Wonderful. And so now let's actually just listen for incoming connections. So we'll do a little print statement here to the screen. We'll say server is listening for incoming connections, ... And then we'll put a new line character there just to give us an idea that this is running. And then the last thing that we'll do is we are going to call our game objects connect players method. And this is what we'll write that will begin listening on our socket to try to let players into the game. So we'll say connect players. Now, nothing's in there right now, but that's not an issue. It'll just, we'll just pass it. But eventually, that's what we're going to run to kick everything in motion. So if we run this right now, let's see, hopefully there's no errors. We'll just get some confirmation that the server is listening for connections, and perfect. So it says server is listening, and everything looks good here. So our server side is blueprinted quite nicely for us to fill in, and we got a really great foundation here. I think this is a great place to stop. In our next video, we'll do the same process, but for our client script. So I'll see you then.